Have you ever wondered if supernovas or black holes are real or just science fiction? Well, today Alex Filippenko, a distinguished professor in the physical sciences, is here to answer some of our questions in this special edition of Grad School Now. What first sparked your interest in astronomy or physical sciences for that matter?
Well, I've been interested in science for as long as I can remember. For example, in the first grade and second grade, I played with magnets in a sandbox, and it would pick up these little tiny bits of iron, which was really interesting. And magnets would either repel or attract each other, so that was interesting as well. And then I, studied circuits and looked through a microscope and got a telescope for a gift and looked at the stars, and it was all just so amazing. In fact, the third star that I looked at with this brand new telescope turned out to be the planet Saturn, which really blew me away, and so I've been interested in science and all my life and in astronomy since high school.
What drives you to continue your work?
Well, I think as with all scientists, we want to discover something new. We want to understand something about the universe that no one has ever understood. And again, going back to the discovery of Saturn, no one told me to point at that star that night. I pointed to it on my own, and it turned out to be Saturn. And so the thrill of seeing it for the first time was amazing. It didn't matter that millions of people had seen it before. I found it on my own that night. And so imagine the thrill that a scientist must get when he or she truly discovers or understands something new for the first time in the history of humanity. So it's that kind of desire to understand nature and to contribute to humankind's understanding of nature.
In 1998, you worked with two teams that discovered the acceleration of the universe, essentially dark energy. What is dark energy?
We don't really know what dark energy is. We know what it does. It's accelerating, it's speeding up the expansion of the universe. Now this is really strange because, when you toss an apple up into the air, it slows down because the Earth's gravity is attracting it. And in a similar way, all of the stars and galaxies in the universe should be pulling on each other, slowing down the expansion of the universe. But instead, we found that it's speeding up. And we don't know the cause, but physicists think that it's a new form of energy that permeates the entire universe. It's a property of space itself called dark energy. And over short distances here on Earth, it has no effect on us. But over gigantic distances, tens or hundreds of millions of light years. Now, a light year is a really great distance. The distance light travels in 1 year, it's a huge distance. But anyway, over such enormous distances, the cumulative effect of this dark energy is to accelerate the expansion of space. And there's now sort of a cottage industry of physicists and astrophysicists trying to figure out what the dark energy actually is.
I understand the discovery was honored in 2011 with a Nobel Prize in the physics. Do you still work with these teams, and how did the collaborations begin?
Yes. In 2011, we won the Nobel Prize in physics for this discovery. It took 13 years for people to become convinced enough that it's correct, and it was verified through other types of observations. And so the team leaders were honored with the prize in 2011. It's a little bit kind of too bad that the Nobel Prize can be given in the sciences to a maximum of 3 people. The Peace Prize can be given to organizations like the Red Cross or the European Union. But in the sciences, it can go only to 3 people at most, and so it's traditionally given to the team leaders. But all the rest of us who contributed, in some cases really a lot, felt honored that the discovery was recognized in such a way. And in fact, the team leaders brought us over to Stockholm to participate in Nobel Week of December 2011. So we had a large number of gatherings, and there were many parties and receptions and all kinds of celebrations. It was just a wonderful thing to participate in. Now, we are continuing to try to study what this dark energy is. I mean, we've identified the accelerating expansion of the universe, but now we want to understand why it's accelerating. And so indeed, we continue to work together. The teams themselves are somewhat different now. They've changed over time, but many, if not most, of the people involved in those early discoveries are still involved in trying to figure out what is going on. And in terms of how the collaboration started, well, we needed a team of people that had the necessary skill set to acquire, analyze, and interpret the observations. So you have some people who might be good at getting data at telescopes, for example, and other people who are good at analyzing those data, and other people who are good at theoretical work, you know, the interpretation and analysis. So you need, in modern science, in most cases, teams of people who will together collectively get the work done, because it's very difficult to be the lone solitary scientist now who can do everything. Most of the easy things have been solved, and so you now work on tough problems that require the expertise of many different people.
Okay. Well, that'll be it. Thank you.
Thank you, and it's a
Professor.
great pleasure for me to visit the University of Texas Pan American. Thank you for inviting me.
Thank you.